Yeah, good day to all. Myself, Dr. G. Srinivas, Assistant Professor in Chemical Engineering at B.V. Raju Institute of Technology, Narsapur. Today, I would like to discuss a topic of different types of interest that are used in industries. So, if you consider different types of industries, they might be using different types of interest for calculation of the various purposes. So, first one is simple interest, second one is compound interest, third one is the continuous interest. So, in calculation of the simple interest, S equals to P into 1 plus IN. So, here what is the P? P refers to the principal amount. So, whatever the principal amount is there, that is designated as a notation of P, and I is the interest rate, and N is the number of years, the duration of the period, that is 2 years, 5 years, 10 years. N equals to number of years, I is the interest rate, P is the principal amount, S is the total amount accumulated after period of years. So, here generally how we calculate simple interest is after period of time, how much of interest amount accumulated is P into I into N. P is the principal amount and I is the interest rate, N is the number of years. And here many people will get confused. I, that is generally interest rate is described generally 5%, 6%, 8%, 10%, 12% in similar manner. So, in how to represent I, it is represented in terms of the percentage. So, I equals to 5% in generally they might be representing. So, I equals to 5 divided by 100. So, interest rate is 0.05. Okay. So, this 0.05 we need to use in calculations. So, this is the principal amount interest amount accumulated period of time. Then total after period of time, how much of amount is accumulated? S is principal amount plus P into I into N. So, if we take P common, then S equals to P into 1 plus I into N. So, in this manner generally we will calculate the simple interest. Okay. For example, if you consider a case that is if $100 of the compensation demanded for a given someone the use of $1,000 for a period of 1 year, the principal would be $1,000 and the rate of interest would be the 100 divided by 1000, that is 0.1 or 10%. 0.1 multiplied by the 100, that will give the 10% per year, or you can name it as 0.1%. Okay. Then total sum accumulated after period of some time, S equals to P into 1 plus I into N. P is the principal amount, that how much of has been given as a principal amount, that is $1,000, then multiplied by 1 plus 0.1 into 1, that will give you the 1000 multiplied by the 1.1. So, after period of time, that is 1 year, the total accumulated amount is $1,100. So, here S equals to total sum, P is the principal amount, I is the interest rate, N is the number of years. After 2 years, if for example in this case S equals to same for after period of 2 years, then in that case we may calculate S equals to P into 1 plus I into 2. Okay. So, N equals to 2 year, 0.1 into 2. So, 0.1 multiplied by 2, that is 0.2, it will give 1.2. 1.2 multiplied by 1000, it will give you $1,200. So, this is the case for second 2 years. Total accumulated amount after period of 2 years. The main difference in the simple interest and compound interest is that the principal amount will be the same in all years for calculation of the simple interest. And whereas in the compound interest, each year the total accumulated amount will be added to the principal amount. Okay, that is the main difference between the simple and compound and continuous interest. So here, while calculating the uh, simple interest, the main problem is that how many days we need to consider for calculation of the interest. Generally, some months may have 28 days, some months may have 30 days, 31 days. So irrespective of that, we have two different techniques to calculate the simple interest. We can name it as a ordinary and exact simple interest. So ordinary simple interest is calculated for the number of days of 360 days, whereas exact simple interest is calculated for total number of days of 365 days. This is the total amount accumulated for a given period of time, that is after 200 days or 300 days or 15 days, 20 days. So number of D is number of days here. Okay, and P is the principal amount, I is the interest rate, and D is the, for both cases, D is the number of days. For example, we would like to determine the how much of interest amount is accumulated after a period of 180 days. So D equals to 180 days. In this formula, we need to substitute D equals to 180 days. Same way, for exact simple interest also, we need to substitute 180 in place of D. Then we will get a small difference. So that is the about ordinary and exact simple interest. So ordinary means we might be considering for the 360 days per year, whereas exact means we are considering about the 365 days per year. That is the simple difference between the ordinary and exact simple interest. And while coming to the compound interest, similar to simple interest, here we will calculate in terms of total sum. Total sum equals to P into 1 plus I whole power n. And here sometimes it may be the interest might be the compounding quarterly, half yearly, or semi-annually. Okay. So monthly basis also sometimes compounding. So in that cases, how we are going to calculate the compound interest? S equals to P into 1 plus R by M whole power M into N. So in this case, P is the principal, I is the interest rate, N is the number of years. So in the second case, S equals to P into 1 plus R by M whole power M into N. R is the nominal interest rate, M is the number of periodic payments, N is the number of years. So M equals to 2 for semi-annually or half-yearly payment. M equals to 4 for quarterly payments. Per year we have 4 quarters. So M equals to 4 for quarterly payments. Compounding. For monthly compounding, M equals to 12. So this is how generally we might be calculating compound interest. S equals to P into 1 plus I whole power N. And for the case of where the compounding has been given as quarterly or half yearly, in that case S equals to P into 1 plus R by M whole power M into N. Okay. And if it is daily compounding, instead of a monthly compounding, if it is a daily compounding, whereas M equals to 365, in that case it is known as the continuous interest. So it is daily compounding only. So S equals to P into E power Rn. So here P is the principal amount, R is the interest rate, and N is the number of years. So R is nominal interest rate and N is the number of years. By using these formulas, we will calculate the what is the total sum accumulated for a given period of time using the simple interest, compound interest, and continuous interest. So, for example, in this case, we might be solving couple of problems. So, first one is calculate how much of amount is payable for a initial loan of rupees 1000 at a simple interest rate of 8% for 5 years. So, in the first case, it is given as how much it is given. So, principal amount is given as here, in this case, 1000 rupees as a principal amount. Interest rate is given as 8%, that is 0.08, and N is given as 5 years. So S equals to P into 1 plus I into N is we can calculate by using this formula total how much of amount is accumulated after period of 5 years. So here P is S equals to, substitute all the components, 1000 into 1 plus I 0.08 into 5. So 0.08 into 5, that is 0.4 plus 1. So 1.4 S equals to 1000 into 1.4, that will give us 1400. Okay, so 1400 rupees is the S equals to total amount accumulated after a period of 5 years. So for the same case, if we calculate for the compound interest, okay, so compound interest S equals to, this is the first case. Second case, S equals to P into 1 plus I whole power N. Okay, so principal amount is same, that is 1000, and 1 plus I is given as 0.08 whole power N, that is 5, that is 1.08 whole power 5. That will give us 1.469, 1000 multiplied by 1.469. So we will get approximately 1469 rupees total sum. So this 69 rupees additionally has contributed because of this compounding interest. And if we calculate the same problem for continuous interest, so S equals to P into E power R into N. So principal amount is 1000 multiplied by the E power R. R is interest rate, 0.08 whole power N, 5 years. So we will get 1.4 1000 multiplied by 1.4918. So we will get 1491.8. This is about the continuous interest. This is the difference amount. You can see 1400 is in the case of simple interest, 1469 in the case of compound interest, and 1491 in the case of continuous interest. This is the how generally we calculate for the different cases. And in addition to the exact simple interest, we can calculate the for how many days, calculate how much of interest amount is accumulated for an initial loan of rupees 1000 at an ordinary simple interest rate. So ordinary simple interest rate, we can calculate how much of amount accumulated for a given of days, that is PID multiplied by D by 360. Okay, so principal amount is 1000, I is given as interest rate 0.06, D is given as 275 multiplied by divided by 360. So we might be getting 0.06 multiplied by 275 divided by 360 into 1000. 45.8 we might be obtaining 45.8 rupees. This is interest amount accumulated after period of 275 days in the case of simple interest. Okay, for the case of exact simple interest, okay, so how much of calculate how much of interest amount is accumulated for initial loan of rupees 1000 at a exact simple interest rate of 6% after 275 days. So for the same case, if we calculate for the exact simple interest, so I equals to how much of amount accumulated after period of 275 days, that is P into I into D by 365. Instead of 360, we have to take here 365. That is the small difference we have. So here principal amount is same, 1000 multiplied by I interest rate is same, 0.06. After period of time 275 days divided by 365. So 0.06 multiplied by 275 divided by 365 multiplied by 1000. 45.20. So this is how much of accumulated amount after period of time of 365 exact simple interest in the case of exact simple interest after accumulated amount of 275 days. So this is how generally we will calculate ordinary and exact simple interest, and we would like to solve few more problems that are relevant to the topic. It is desired to have $9,000 available 12 years from now. If 5,000 is available for investment at present time, what discrete annual rate of compound interest on the investment would be necessary to give the desired amount? So it is stated as a compound interest. So these are the previous gate problems. So S equals to P into 1 plus I whole power n. So here we have S equals to it is desired to have $9,000 available 12 years from now. If 5,000 is available, so here principal amount is given as $5,000 and S is given as $9,000. So here we don't know the annual rate of compound interest, but N is given as 12 years. So S equals to P into 1 plus IN. So if you substitute the all components, 9,000 equals to principal amount 5,000 multiplied by the 1 plus I we don't know, whole power n, 12. So you can take 5,000 to left hand side. So 1.8 equals to 1 plus I whole power 12. Multiply both sides with 1 by 12. So 1.8 whole power 1 by 12 equals to 1 plus I, 12 into 1 by 12. So 12 get cancelled. So 1.8 whole power 1 by 12, that will give us 1.05, that equals to 1 plus I. So take 1 to left hand side. So I equals to 1.05 minus 1, that will give us 0.05 as the interest rate. Okay, in this problem just we need to substitute the given component. Principal is given as 5,000. So total sum, desired sum is given as 9,000. Period of time is given as 12 years. So our formula for calculating the compound interest, S equals to P into 1 plus I whole power n. So substitute given components, then we will get the I equals to 0.05. Okay. In the same way, we will solve another problem. What will be the total amount available 10 years from now if 2,000 is deposited at present time with nominal interest rate of 6% compounded semi-annually? So here we have S equals to P into 1 plus R by M whole power M into N. So this formula we know that for a different quarterly or half yearly payments, how to calculate total sum accumulated. So principal amount is given as $2,000 and interest rate, nominal interest rate is given as R equals to 0.06. M is given semi-annually. Semi-annually means annually 2 payments. So M equals to 2. So N equals to given 10 years. Okay. So substitute the given components. P is $2,000 multiplied by 1 plus R 0.06 divided by m. M is given as 2 whole power m into n, 2 into 10. So we will get approximately 0.06 divided by 2, 1.03 whole power 20 multiplied by 2000. So 3612.2. This much of amount dollars will be available after 10 years if the semi-annually it has been compounded. And similar to that, we will solve another problem. An original loan of $2,000 was made at 6% simple interest per year for 4 years. At the end of this time, no interest had been paid and the loan was extended for 6 more years at new effective compound interest rate of 8% per year. So initially they have considered for simple interest. After a period of time, they have changed it to compound interest. And what is the total amount owed at the end of the 10 years if no intermediate payments are made? So initially we'll calculate for 4 years. S equals to simple interest here, P into 1 plus I into N. Principal amount is given as $2,000. Okay. I is given as 6%. N is given as 4 years. So total S equals to 2000 multiplied by 1 plus I, 0.06 into 4. So how much of amount we might be getting? 0.24. So 2480 is the for at the end of the first installment period, that is yes after 4 years. But they have stated that no intermediate payments have been made and the loan has been extended for 6 more years. And in the next upcoming 6 years, it has been stated as compounding 8%. So principal amount here will be the 2480. Okay. Then I, interest rate is given as 8%, 0.08. N equals to given as 6 years. Total 10 years. Initially for first 4 years simple interest, remaining 6 years compound interest. So here S equals to P into 1 plus I whole power N. So principal amount here after 4 years there were no intermediate payments have been made. So whatever the interest amount accumulated, it has been added to principal amount. So that will become as a 2480 multiplied by 1 plus I. I is given as 0.08 whole power N. N is given as 6. So 1.08 whole power 6. 1.58. So 2480 multiplied by 1.587. So we will get a 3935.76. So this is the total amount they need to pay at the end of the 10 years. Okay. In this case, first 4 years they have calculated the in terms of the simple interest for 4 years. So 4 years, how much of amount accumulated is? Total amount is 2480. Okay, that will become as the principal for the next 6 years. So principal is 2480 and here onwards it was stated as the compounding interest. So compounding interest we need to consider. N equals to 6, I equals to 0.08. So if we substitute the all the things, then we might be getting 3935.76. So this is the one problem, it is given previously in GATE. An investment of rupees 1000 is carrying an interest of 10% compounded quarterly. The value of the investment at the end of the 5 years will be. So how much of amount will be available after 5 years? Okay. So here principal amount is given as a 1000 rupees, and the interest rate is given as 10%, that is 0.1. Compounded m equals to quarterly. Per year we have 4 quarters, so m equals to 4. For 5 years, n equals to how many years? For 5 years. So total sum S equals to P into 1 plus R by M whole power M into N. So principal is given as 1000 multiplied by 1 plus R is given as a rate of nominal interest rate, that is 0.1 divided by M. It is stated as compounded quarterly. So M equals to 4 multiplied by the N for 5 years. So 1000 multiplied by 1.6386. So we will get 1638.6 rupees available at the end of the 5 years. This is very simple problem. Only thing is that we need to quarterly payments, it has been stated. So M equals to 4 we need to substitute, and if it is stated monthly payment, then M equals to 12, and if it is stated semi-annually, then or half yearly, M equals to 2 we need to substitute in this formula. So this is about the simple interest and compound interest and continuous interest and calculation. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.